how do you actually build a sliding door like this? In this video, I'll show you the whole process step by step. We hope you enjoy watching. The first step involved cutting the frame timbers for the door to size. These are 6x8 kVH construction timber, so the door will be quite substantial. I roughly aligned everything on the trailer, laid it out, and now we're marking it all out so we don't get confused later and can easily put each piece back in its place. We've marked out a triangle for this. The wooden frame pieces were joined with a simple lap joint. We will now make these. This is quick and easy to implement, unlike other joints. I decided to cut the wood using a miter saw. For this, however, it needs to be depth adjustable, that is to say, lockable, so that we can set the desired cutting depth and it won't change. Now the excess wood can easily be removed with a chisel, but for this, we really need a sharp tool. A dull chisel won't get us very far. That means we need to get the whetstone out of the water and sharpen the chisel. And this connection can be cleaned with little effort. Now we come to the finishing touches, quite literally, and afterwards the joint can be glued and secured with bolts. The joint will also be secured with a carriage bolt. To ensure the nut doesn't protrude on the other side, a Forstner bit was used to pre-drill a hole for countersinking, and this will then be covered with a cap. We'll get to gluing the door together in a moment, and we'll also discuss which glue is best for this. Before that, however, the door needs to be aligned so that all the parts are at right angles to each other, ensuring the door isn't crooked or warped later. That would, of course, be a rather unusual sight, let's just say. The adhesive used here is PU adhesive. This type of adhesive expands and is suitable for outdoor use, so it's a D4 adhesive. It's important to ensure that any adhesive used outdoors is waterproof. I would actually recommend doing the same for indoor applications. You never know. This door will have a wooden panel in the lower section, and a window will be installed in the upper section. To visually separate these two sections, we have incorporated a crossbeam into the door. An X shape has now been incorporated into the lower section. This gives the door more stability. I didn't do much measuring for this. I simply placed the board underneath, marked it, and cut it to size. The same process was used for the second board. This is what it looks like now, and as we can see, the boards are essentially still stacked on top of each other, and they need to be on the same surface, on the same plane, so that they are flush later. Therefore, half of each side was notched out again. Now we have our infill here, which we're currently preparing, or rather filling. For this, we have these tongue and groove boards, which are also called floorboards. The advantage here is that they're already nicely planed on both sides, nice and smooth. We don't need to do much preparation at all, no sanding or anything like that. We just need to put them in. I cut them to a really precise fit, so they go in snugly. And so that I don't hurt my fingers while hammering them in, I have this little rubber mallet here. It works perfectly. And then I can tap the tongue and groove nicely without them breaking. And then they're hammered in like this. The door was then turned once and subsequently screwed in from the back. So now the screws are no longer noticeable. The infill itself could still fall out, of course. For this, we've prepared and fitted these retaining strips, which will hold the infill in place. We simply used decorative strips from the hardware store and nailed them on. With minimal effort, we have now made our own decorative moldings. First, they were profiled using a handheld router and then cut to length with a handheld circular saw. We needed these to cover the joints between the boards in the infill, as these can be exposed due to swelling and shrinkage, especially during periods of severe drought in summer. And to make this less obvious, we covered them with the decorative strip. Now we come to the components that transform a sliding door into a sliding door. For this, we need the lower guide rail, which we can see here. This will be recessed into the door and guides the door from below, ensuring it always stays straight and doesn't swing. The upper guide rail is mounted on rollers, which we'll get to shortly. The lower guide rail is now recessed into the door. I've pre-cut it, and then we'll continue with a handheld router. This small handheld router doesn't have much power, which means we have to route the whole thing bit by bit until we reach our desired depth. I think the profile was 3x 3 centimeters, so we needed a depth of 3 centimeters here. Are you already subscribed to this channel? If not, please consider subscribing for free. This supports the channel and ensures you don't miss any content. Thank you. The rail is already holding quite well, but it was also additionally secured at the bottom with 3 screws. As you can see here, I didn't work all the way through, so that from above, when you open and close the door, you can't actually see the metal profile. The rollers are being attached to the door right now. We're using a small metal plate for this, which we've attached to the door. A hole was drilled beforehand. This allows for easy height adjustment of the door as the roller assembly is screwed into this metal plate. I found this sliding rail system to be very well designed. The best part is that it can be individually adjusted to fit any door exactly how you want it. Here we have our sliding door track system. It consists of 2 tracks. The stopper just came off. That's basically the door stopper, and it's held in place by these small brackets here. We have some that you screw onto the top. The track goes in here, and the door is attached to these rollers. We have them here, and these rollers run in the track and guide our door. The stopper goes in here last, and then it stops the door. And we'll show you how we assemble the whole thing next. We opted for ceiling mounting here. However, there's also a wall mounting option, for example, if you want to install it on a garage door. Assembly is incredibly simple. There's practically nothing you can do wrong. The only thing to keep in mind is to make sure the track is stable and doesn't tilt. And of course, the track should be perfectly level so the door doesn't keep opening and closing on its own. The track length can easily be shortened to suit your needs. To prevent the door from opening too far or sliding out of the track, stoppers with a rubber buffer are available, and the whole thing can be screwed into the top of the profile. The door is hung and has been coated with wood preservative. Now we can see the glazing beads. The glass pane is here and will be installed in the next step. As you can see, a black compression tape has been glued into the glazing beads. This is a foam-like sealing tape. It prevents water from getting in, seals the gap, and also provides a bit more protection for the glass. This is double-glazed safety glass. It was ordered from a local glazier. Here we see the pane being shimmed. This is done with glass blocks. These are made of plastic in my case and prevent the pane from wobbling, ensuring it sits firmly in place. The mounting strips were all cut to size with a miter saw. The cuts were mitered, and each strip was cut 1 to 2 millimeters longer than the original length. This ensures a precise fit at the miter joint, eliminating any visible gap. Now we need to be careful so we don't break the window.